Hi everyone, in today's lesson we are going to talk about inverse functions. I first want to talk about how you first heard of an inverse in geometry. To find the inverse of a figure, you would reflect all the points over the line y equals x. So in geometry, this was a type of line reflection. You take this figure here and you flip it over this line and you get this figure over here. So what do you notice about the coordinates? Point A flipped over to here, point B flipped here, point C flipped here. So what do you notice about point A? A went from -4, 2 to 2, -4. B went from -3, -1 to -1, 3. C went from -5, -2 to -2, -5. So what should you be noticing? You should be telling me that all the coordinates switch places. So when you reflect a point, or a set of points, over the line y equals x, in order to do that, you just switch the x and y values. So in geometry, what you did was you switched and flipped figures. In Algebra 2, we are going to flip functions over the line y equals x. So here in this picture, this is the line y equals x. This is some function here which looks exponential to me because it goes through the point 0, 1. So we're going to take this curve and flip it over this line, and we get this curve here. So what we're going to talk about in Algebra 2 is how to do this first algebraically, but this is what it looks like graphically. So let's fill in the blanks. To find the inverse of a function, we will reflect the entire function over the line y equals x. So again, same thing as geometry, but now we're going to reflect all of the points that make up this curve and flip it over this line, and all those points that we would get would make this curve here. So we're just going to connect a few points and make the inverse function. And again, to find the inverse function, we will do what? We will switch the x and y values. Okay. Now it's time to introduce function notation and inverse notation. Function notation you've seen before as f of x. We could use g of x or even k of x or whatever, but f of x and g of x, they all mean y equals. Now if I want to introduce something called inverse notation, if I'm asking you to find the inverse, I'd have to write f -1 of x or even g -1 of x. It's the same thing, just I could use a different letter, and that all means to find the inverse. So when I'm given a function, f of x, blah, 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 find the inverse relation. So a relation is just a set of points. Okay, and that's what this is. This is a set of a whole bunch of points. Find the inverse relation. So f -1 is how we write the inverse. So f of x is the original, f -1 is my inverse. So we're going to switch the x and the y values just as we did before. So 3, 4 becomes 4, 3. 1, -2 becomes -2, 1. 5, -1 becomes -1, 5. 0, 2 becomes 2, 0. And what I just did here is an inverse relation, another set of points. Now this question is this inverse relation, this set of points, is it a function? Well, we say a relation is a function if all the x values are paired with exactly one y value. So let's examine it. 4 is paired with 3. Is there another 4 that could be paired with something else? No. -2 is paired with 1. No other -2s. -1 is paired with 5. 2 is paired with 0. So I would say yes. Okay? Let's look at a different example. So example number 2. We have it now in table form. So we have x and f of x. And we want to see, first find f -1 of x. So get used to seeing this notation. This means to find the inverse. Okay, so why don't you try this one on your own and then hit resume when you're done. Okay, this should be your answer. So basically, all I did was take these points, negative 3, 5, and flipped it. 5, negative 3. Negative 1, 6, I made it 6, negative 1. 0, 7, made 7, 0, and then so on and so on. And the question is this inverse relation also a function? My answer was no. And my answer is no because of these 2 points, here and here. Do you see how this x value of a 5 is paired with this negative 3, and this x value of a 5 is paired with 4? That can't happen. The definition of a function says every x must be paired with one specific y value. This 5 is paired with a negative 3, and this 5 is paired with a 4. So I said no because the x value of 5 is paired with negative 3 and 4. Pause the video if you need to write this down, and then hit resume when you're ready to continue. Okay, I'd like to take the moment to review compositions of functions. This will be helpful a little later on, and I think it would be useful if we reviewed it. So, given f of x is equal to this function, and g of x is equal to this function, I'd like you to find f of g of x. So if you recall, f of g of x means f of g of x. So it helps if you exaggerate these parentheses a little bit, because you want to put this g of x function here into f. So what is g of x equal? G of x equals this. So I'm going to replace g of x with what it is equal to. So all I did was say, okay, g of x equals this. So now I want to find f of this. So everywhere I see an x, I'm going to put this instead. So if this is your f of x function here, and I want to find f of x squared minus 3x plus 1, wherever I see this x here, I'm going to put in this x. So I'm going to substitute it here for this. So it's 3 times something plus 2. That's where I got this from. So that something is going to be x squared minus 3x plus 1. And you can distribute. So you'd get 3x squared minus 9x plus 3, and then plus this 2, and combine like terms, plus 5. So this would be your final answer. So f of g of x means to put the g of x function into the f. Okay, let's move on to the next page. Now we are finally ready to find the inverse function algebraically. So if we're going to do it without a graph, we're going to do it the same way as if we had a graph. We're going to start by switching the x and y values. So let's look at example number 1. Given y equals 2x plus 3, find its inverse. So switch the x and y values. What that means is everywhere I see a y, I'm going to put an x, and everywhere I see an x, I'm going to put a y. So look, I took the y, I switched it to an x. I took this x and I switched it to a y. Plain and simple. Then you're going to solve this equation for y. When you're done, this will be your inverse function. So here's my new y, and I need to solve for it. So I'm going to subtract 3 on both sides. I'll get x minus 3 equals 2y. Now divide each piece by 2. These will cancel. So you're left with y equals, technically there's a 1 there, so you could say 1/2 x minus 3 over 2. Now, how do I know, how is there a distinction between the original function and now its inverse function? Well, you have to write your final answer as f negative 1. So what you just found, this piece right here, is your inverse function. So it's only proper to note it that way. So this, here in red, is your preferred answer. It's your answer because you wrote it in function notation. You used f negative 1 of x. So just to recap, what did we do? First things first, we switched every y to make x and every x to make y. Then we solved and did some algebra and solved for y, and then just wrote it with f inverse, f negative 1 of x. Okay, let's try second example. So the second example says, given f of x equals x plus 1 over x, find f negative 1. So again, f negative 1 of x is the same thing as saying find the inverse. So this f of x is the same thing as saying y equals, so let's go ahead and do that. Now I can switch my x and y values. So every y I'm going to put an x. Every x I'm going to put a y. Now, this looks like a fraction on one side, not a fraction on the other. So I could put this over 1, and I can cross multiply. So x times y is xy. Y plus 1 times 1 is y plus 1. Now, half of you may be thinking, my next step is to solve for y. This one's a little funky because I've got a y on this side and a y on this side. So the best way to solve this is to put the y's on the same side. So we have xy minus y equals 1. And the only way to get these y's separated is by taking out a GCF of y. If we do that, we're left with x minus 1. So watch. I did xy divided by y, I got x. Y divided by y, I got 1. So now I can get y by itself by dividing by x minus 1. So your final answer, right up here, is y equals 1 over x minus 1. Again, we should probably use function notation. So the inverse, f negative 1 of x, is 1 over x plus 1. X minus 1, sorry. Okay, let's try the third example. The third example says f of x minus 12 equals 3x. So again, f of x is the same thing as saying y, so we have y minus 12 equals 3x. Okay, so part A says find the inverse. Please pause the video and find the inverse of this function. It's not necessary to get this into y equals. Okay, so what you should have done was said, okay, y minus 12 equals 3x, and switch the x and the y values. And then divide each piece by 3 to solve for y. So y was equal to 1/3 x minus 4, because 12 divided by 3 is 4, and to write it in inverse notation, f negative 1 of x, it would have been 1/3 x minus 4. Excellent. Now the second part says find f of 5. F without this inverse notation is just the original function. So this means what is the value of y when your x value is 5 in the original function? So f of x minus 12 equals 3x. Let's get this to y equals, make your life a little bit easier. So f of x equals 3x plus 12. And I want to find f of 5. So everywhere I put an x, I'm going to put 5. So f of 5 is equal to 3 times 5 plus 12. Put this side into the calculator. So f of 5 should be equal to 27. Okay, now what does it mean to do f negative 1 of 5? That means look at your inverse function and plug in 5. So here's my inverse function, f negative 1 of x, and I have 1/3 x minus 4. I want to find f negative 1 of 5. So everywhere I see an x, I'm going to put a 5. Now put this side into the calculator just the way you see it and get the value of f negative 1 of 5. Okay, you should have gotten negative 7 over 3. Okay, let's do this last one. So this last one says find f of f inverse of 5. So just like we did before with the compositions, we want to find f of f inverse of 5. So first we want to find out what f inverse at 5 is. And hey, wait, we just did that. We did that over here. So f negative 1 of 5 is negative 7 over 3. So all I'm going to do is say now I want to find f of negative 7 over 3. So f is the original function, and I want to put in negative 7 over 3. Here's my f of x function, so I'll write it again. So f of x equals 3x plus 12. And I want to find f of negative 7 over 3. So everywhere I see an x, I'm going to put negative 7 over 3. Now put this into the calculator just the way you see it and see what you get. Alright, you should be getting 5. So look what happened. When you do f of f inverse of 5, you get back 5. That's interesting. that should help us with this last page. There's one last important fact about inverse functions. We say that two functions, f and g, are inverses of each other if we compose them one way, f of g of x, and then compose them the other way, they both should equal x. So let's try the first example. So we're going to do first f of g of x, and then we're going to do g of f of x, and we're going to see that they both come out to x. Okay, so again, f of g of x, which is here, and g of f of x over here, when we do them, they both need to come out to x. So this first example is f of g of x. What that means is do f and throw g of x inside. So we're going to take this g of x function and put it into f. So we're going to start with f of x. f of x is 2x plus 1. And I want to find now f of 1/2 x minus 1/2. Where that came from was, well, I just replaced this g of x with what it was equal to, the 1/2 x minus 1/2 from right here. So I'm putting into the f function this. So now everywhere I see an x, I'm going to put this instead. So I've got 2 1/2 x minus 1/2 plus 1. So let's distribute. 2 times 1/2 is 1, so 1x. 2 times 1/2 is 1, so minus 1 plus 1. Well, let's combine like terms. These will cancel. I'm left with this 1x, or just in fact x. So this came out to x. Now we just got to see that the other side does as well. So again, f of g of f of x is the same thing as saying g of f of x. So I'm going to throw f of x into g. So instead of f of x, let's write exactly what it's equal to, which is this, 2x plus 1. So I want to find g of 2x plus 1. So start with the g of x function. And I want to find g of 2x plus 1. So every time I see an x, I'm going to put 2x plus 1. Alright, so now let's distribute. 1/2 times 2 is 1, so 1x. 1/2 times 1 is 1/2. And then bring down the minus 1/2. So what's 1/2 minus 1/2? 0, they cancel. And we're left with 1x or just x. So, perfect. They're both inverses of each other because they both come out to x. Awesome. So, yes, put a little check. Proves f of x and g of x are inverses. Okay, why don't you see if you can try the second one all on your own. Pause the video and hit resume when you're done. Actually try it this time. Okay, this should have been your answer. When you did f of g of x, you should have got this. And when you did g of f of x, you should have got this. Now, after this, you really could have stopped because it doesn't equal x, so it's no good. So no, f and g are not inverses of each other. If you need to look at the work again, pause the video, look at it, and come in with questions tomorrow. All right, see you guys tomorrow.